Welcome to another video in the surprising shortcut series. Today we will consider a summation question, question 10 from the Edexcel A-Level Further Pure 1 from June 2013R. The question requires us to find the closed form of the summation of r squared minus 2r plus 2n plus 1, from r equals 0 to n. The standard method uses the formula for the sum of squares and sum of integers. This involves doing 4 separate summations, and then factorizing, combining, and simplifying terms. This can be quite a tedious and messy process. After all that messy algebra, we arrive at the final answer as shown. The answer looks very similar to the formula for the sum of the first n squares. Upon closer inspection, we find that it is actually the sum of the first n plus 1 squares. Now we ask ourselves, can we convert the original summation into the sum of the first n plus 1 squares directly, without first getting to the final answer? If we can do this, then the answer is just one step away, and we avoid all the messy algebra. Let us try. First we combine minus 2r and 2n, and factorize 2. Before the next step, consider a little diversion. Note that 0 plus 1 plus 2 plus 3 equals 3 plus 2 plus 1 plus 0. In other words, the sum of r, for r equals 0 to 3, is the same as the sum of 3 minus r, for r equals 0 to 3. Generalizing this to n, we get the formula in the blue box. Now back to the derivation. Using the formula in the blue box, we can replace the summand n minus r, with r. This is because the summation is taken from 0 to n, so we now have the sum of r squared plus 2r plus 1. This is just r plus 1 squared. We can increase the index by 1, and write this as the sum of r squared from 1 to n plus 1. So now we have successfully converted the original summation into the sum of the first n plus 1 squares directly, without expanding the summation. Now apply the formula for the sum of squares but using n plus 1 instead of n, and we have the final answer. This method avoids the messy algebra in the standard method. It is also more intuitive as it shows how the original summation is actually the sum of the first n plus 1 squares. Here we show the full solution, using this alternative method. We hope you enjoyed this video. Please like, subscribe, and leave a comment below. Thanks for watching.